Hello everyone, welcome to my YouTube channel. In this video, I am going to explain current series feedback amplifier analysis. So this figure shows the basic block diagram of a current series feedback amplifier. Here, current sampling is taken at output and series mixing is used in the input side. I will explain this topology with the help of small logic. Okay. In current series amplifier, current sampling is taken at the output. Okay. So any negative feedback amplifier has two blocks. One is amplifier. One is amplifier represented by letter A. Another block is feedback network represented by beta. Beta. Okay. So obviously a load resistance is connected to the amplifier or yeah. In current series feedback amplifier, current sampling is taken. Current is constant at series. Series low current constant amount. So here same amount of output current is applied to the input. That's why here series connection is required. Series connection is required. Output side series connection is required. This is series connection. Coming to the input side, series mixing is used. Series mixing is used. Okay. Input side series mixing is used. So here series mixing is used. So series లో కరెంట్ కాన్స్టెంట్ గా ఉంటుంది బట్ వోల్టేజ్ ఎఫెక్ట్ అవుతుంది. సో therefore here voltage source Vs is connected. So which parameter is affected in series connection? Voltage. Okay. Current is constant. That is why here Vs is connected. So the output of feedback network is the Vf. Vf. ఇక్కడ ఏ పారామీటర్ ఉందో సేమ్ పారామీటర్ ఇక్కడ కూడా ఉండాలి. సో ఇక్కడ వోల్టేజ్ ఉంది కాబట్టి ఇక్కడ కూడా వోల్టేజే ఉంది. ఓకే. సో ఎనీహౌ ఇట్ ఈస్ అవుట్పుట్ ఆఫ్ ఫీడ్బ్యాక్ నెట్వర్క్. దట్స్ వై ఇట్ ఈస్ రిప్రజెంటెడ్ బై V suffix f, Vf. So Vs and Vf both are out of phase with each other. Why? Because it is a negative feedback. So obviously here we will get Vi. So Vi is equal to Vs minus Vf. The source parameter and the output of voltage parameter must be the same. That is very, very important. So here voltage is there. That's why here also voltage. Okay. So Vi is equal to Vs minus Vf. Output sampling current I naught. Output sampling is current. So I naught. So this is also series connection. This is also series connection. Okay. So now coming to the formulas. Amplifier gain. Amplifier gain. ఇక్కడ గెయిన్ అని మాత్రమే యూజ్ చేశాను, వోల్టేజ్ గెయిన్ అని యూజ్ చేయకూడదు. ఓకే. యాంప్లిఫైర్ గెయిన్. వాట్ ఈస్ ద అవుట్పుట్ ఆఫ్ యాంప్లిఫైర్? I naught. I naught is the output of amplifier. So I naught divided by, what is the input of amplifier? Vi. So I naught divided by Vi. Similarly, AF, amplifier gain with feedback. AF is equal to overall output is I naught. Overall input Vs. I naught divided by Vs. Beta. Beta is equal to output of feedback network is Vf. Vf. Input of feedback network is I naught. I naught. So I naught. Vf by I naught. Beta is equal. Now coming to the equivalent circuit. Equivalent circuit. So we know that A is equal to, in current series feedback amplifier, A is equal to I naught divided by Vi. So first we have to draw the output portion of the circuit. Here output parameter is represented in terms of gain. So I naught is equal to A into Vi. A into Vi. So A into Vi is the current source, that is equal to I naught. So here current source. According to Norton's theorem, equivalent resistance or not is connected in parallel or not. Of course, there is a load resistance called RL. Load resistance RL. Now input side. Input resistance is represented by RI. RI. So current series, in series mixing, voltage is affected. That's why here Vs is connected. Vs is connected. Now coming to the feedback network, beta. So output side, current sampling. So here current sampling is used. That's why series connection is required. Okay. And input side, series mixing. Series mixing. Here also series connection is required. Also series connection is required. This is the basic equivalent circuit of a current series feedback amplifier. Current series feedback amplifier. Okay. Now coming to the derivation. Gain. So gain AF is equal to overall output is I naught because of current sampling. Overall input Vs. So I by V is the conductance. Okay. So one parameter I naught belongs to output and another parameter belongs to input. So that's why here trans term is used. So it is also called trans conductance amplifier. Okay. Now we know that Vi is equal to Vs minus Vf. Why? Because here just observe this figure, this topology. Here Vs is there. Okay, here Vf is there. So Vs minus Vf is equal to Vi. Vs minus Vf is equal to Vi. Okay, that is the amplifier input voltage. So we know that Vi is equal to Vs minus Vf. So Vs is equal to Vi plus Vf. Okay. So instead of this Vf, here beta into V naught is substituted. Sorry. Instead of this Vf, beta is equal to, we know that Vf by I naught. Okay. So instead of this Vf, here beta into I naught is substituted. Not V naught, beta into I naught. Why? Because beta is equal to Vf by I naught. Now, Vs is equal to Vi plus beta into I naught. Okay. Now coming to the amplifier gain. Amplifier gain A is equal to I naught divided by Vi. I naught divided by Vi. So instead of Vf, from this formula, instead of Vi, I will substitute I naught divided by A. I naught divided by A. Why? Because A is equal to I naught divided by Vi. So Vi is equal to I naught divided by A plus beta into I naught. So I naught is taken common, we'll get 1 by A plus beta. That is equal to Vs. So Vs is equal to I naught into 1 by A plus beta. So Vs is equal to I naught into 1 by A plus beta. So A is the LCM. So 1 plus A beta. 1 plus A beta divided by A into I naught is equal to Vs. So amplifier gain with feedback AF is equal to overall output I naught divided by Vs. Okay, this is the formula. So I naught by Vs, simple cross multiplication. Simple cross multiplication. I naught by Vs is equal to A divided by 1 plus A beta. So I naught by Vs is nothing but amplifier voltage gain. AF is equal to A divided by 1 plus A beta. This is the gain of a current series feedback amplifier. Now coming to the input resistance derivation. Coming to the input resistance derivation. Input resistance RIF is equal to Vs divided by Ia. Here current is same in series mixing. Voltage is affected. That's why here Vs is considered. Ri is equal to amplifier input resistance Vi divided by Ia. We know that Vs is equal to Vi plus Vf. So Vi plus Vf is equal to beta into I naught. Why? Because beta is equal to Vf divided by I naught. So Vf is equal to beta into I naught. Again, I naught is equal to, we know that amplifier gain is equal to I naught divided by Vi. So I naught is equal to A into Vi. So therefore Vs is equal to, here Vi is taken common, we'll get 1 plus A beta. So both LHS and RHS is divided by II. So Vs by Ii is equal to RIF. RIF. So RIF is equal to Vi divided by Ia. So Vi divided by Ia is equal to Ri into 1 plus A beta. So because of series mixing, input resistance of current series feedback amplifier is increases by the factor of 1 plus A beta. Now coming to the output resistance derivation. Coming to the output resistance derivation. Okay. So to get output resistance, input must be equal to 0. What is the input here? Vs is equal to 0. So we know that Vi is equal to Vs minus Vf. Put Vs is equal to 0, we'll get Vi is equal to minus Vf. Now again draw the output portion of the circuit, equivalent circuit. Here current mixing, amplifier gain A is equal to I naught divided by Vi. So this is A into Vi. So this is current source and equivalent resistance according to the according to the Norton's theorem. So R naught is connected here, and instead of RL here voltage is applied to get output resistance. That is here this voltage is represented by V naught. Now coming to the current. Coming to the current formula. I naught is equal to, this is I naught. I naught is equal to V naught divided by R naught plus A into Vi. So here instead of Vi, simply minus Vf is substituted. V naught by R naught plus A into minus Vf is substituted. So I naught is equal to V naught by R naught minus A into, instead of Vf here, beta into I naught is substituted. Obviously we'll get I naught plus A beta I naught is equal to V naught by R naught. Now next step, from this equation here I naught is taking common. I naught is taking common. 1 plus A beta is equal to V naught by R naught. Simple cross multiplication, V naught by I naught is equal to R naught into 1 plus A beta. So here R naught is equal to output resistance of feedback amplifier. R naught is equal to output resistance of amplifier. V naught by I naught is equal to output resistance of feedback amplifier. So ROF is equal to R naught into 1 plus A beta. So output resistance of a current series feedback amplifier is increases by the factor of 1 plus A beta. Thank you.